Hi, my name is Mohammed Khan, and for my individual assignment, I've done the Type 1 project, which is a web application called WindSpeed Calculator. Now, what is a WindSpeed Calculator? So, a WindSpeed Calculator, it's a software as a service that will allow various users such as engineers, builders, shed sellers, and other professionals from various industries to leverage this application and calculate a precise design wind speed. And this design wind speed, which will be in meters per second, is a crucial element, is an important factor that engineers use in the analysis and design of various structures such as buildings, sheds, bridges, and other structures. With respect to the technology, I have leveraged the Google Cloud Platform, and I've used the Kubernetes engine on the Google Cloud Platform. I've used the Cloud SQL database on the GCP, and specifically I've used the Postgres SQL. For my front-end application, I've used JavaScript, which is a SPA application built using React.js and TypeScript. And for my backend API microservices, I've got three services running respectively. One of them is built on Node.js Express framework. The other one is built on Python using Flask framework. And the other project or the other service is built using .NET technology. Now, to understand how the application works, how the wind speed calculator works, this is a C4 diagram. It's a combination of the component and the container diagram that gives us an insight as to how the application works. So users such as engineers from the web browser that be able to key in the URL of the application, and the request would go through an external load balancer in the GCP, and it will then, from one of the nodes in Kubernetes, it will then extract and in the bundle, the JS bundle, the minified bundle, and that will be then returned back to the browser. So the application will actually run from the browser in using that minified bundle. And every request from there on, such as if the user logs on, the request would the HTTP request would then go through a ingress application load balancer and distributed to the respective backends. So in this case, the user is trying to log in. The request will go through the identity API service, which is a service that is built on Node.js which is a service that is built on Node.js, and so this service will communicate to the database and authenticate the user and eventually return a JWT token back to the application that's running on the browser. And if the user is trying to do CRUD operations, then the request would end up in the building API service, which is built on the .NET technology, leveraging the C# programming language. And if the user is trying to do a calculate, then it will end up in the WindSpeed calculator API service, which is built on the Python Flask framework. And the database itself is a cloud database, and the way that the services communicate to the database is using a private IP, and hence it is very secure as well. So as with respect to the database, I've only got two tables in the database: users and buildings or jobs. And the relationship between them is that one user can have many jobs or buildings, and one building or job belongs to only one user. Now let's quickly look at the application and see how it works. So the user will be able to log in to the WindSpeed calculator via the login screen and by entering their credentials. And once logged in, they will have their own dashboard, own reporting, job listing as well. So they'll be able to navigate to jobs or create a new job, or in this case, let's go to the jobs of the user that has logged in. So once they click on jobs, it will list all their jobs. So at the moment I have few jobs for this user, and if we open up one of them, let's say job number 2, it will open up the job details that will show us the building or the job related details on one side, and the calculation inputs on one side. Now note, if I change anything with respect to the building details and try and save, it will trigger the building API service that we have. But if I change anything here with respect to the calculation inputs, then it will update the calculated design wind speed, and this is being computed by the Python service that we have running, which is the calculator service. The user can change any details here, and they will be able to save, and that will say that job has been successfully saved. The user can come back to that job again, and the information will be retained, and eventually the user can log out from the application. Alright, now let's look at the GCP Kubernetes engine to see how our application is running. So I was able to use the get all command to get an overview as to what's running. So you can see there's about 5 pods running. There's some services as well. A couple of them are load balancers. One is for the front end web app, and the other one is for my PG admin service that I use to interact with the database. These are my deployments. So the first 3 deployment is with respect to the backend services of the application. The second last one is for the PG admin, just to interact with the database, and the last one is for the front end deployment. And I also have an ingress controller running as well, which eventually on the cloud is the application load balancer. Now, to show you scaling, I was able to use the scale command and set the replica set to 5, and this was for the building API deployment. So initially I had 1 running, so I was able to use that command and get 5 of the pods running. Now to scale down, all we have to do is change the number of replicas and change to a desired number, and then run that command, and that will handle the scale down for us. With respect to the rollout, before rolling out the building API deployment, I wanted to quickly describe, using the describe command, just to check as to what version that building API deployment is on, and at the moment it's on version 2. I was then able to use the set image command to set the image to a newer version, which is version 3 for the building API deployment. And eventually I was able to check the rollout status with the rollout status command, and finally I was able to validate by describing the building API deployment and confirming that the new version is in place, which it is version 3. So the deployment was successful. With respect to rollback, I was able to roll back from version 3 to version 2 by using the rollout undo command for the building API deployment. I was able to look into this status as well, and eventually when I described the building API deployment, I was able to confirm that the building API deployment is now using version 2 for the image. And finally I was able to delete one of the pods just to demonstrate the self-healing feature. I was able to delete one of the pods, and the Kubernetes engine automatically spun up a new building API deployment pod, and this shows to us that was only done by the Kubernetes engine in the last 4 seconds, and I was able to delete the pod using the delete pod command. In conclusion, I would say that the technologies that I've used for the WindSpeed calculator application is a true fit for this application. A lot of the professionals in the industry will completely rely on this web application to give them a precise design wind speed. And it is of paramount importance, it is imperative that this application is running all the time. So the use of the Kubernetes technology will help us to ensure that the application is scalable and available. If there are a lot of users trying to use the application across Australia and New Zealand, this engine will ensure that the application is scalable and available to meet the demand, and at the same time it's fault tolerant as well. The microservices approach that we've taken, the architecture, will help independent development teams to work on various services, completely different teams working on these services, and as a result they can use their own technology stack and they can have a separate DevOps procedure as well. And finally, the use of the managed cloud database, and we've used Postgres in this case. It will also help in reducing the overhead from the development team, and it will help in managing the infrastructure, the database related tasks such as replication, backing up, availability and scalability. Thank you.